Okay, so on worksheet 6, proofs, we're going to start out with a bunch of vertical proofs using the definition of vertical angles and the vertical angles congruence theorem. We're also going to work with right angles. Then it will move into some kind of mixed review. So as always, everything we've learned is still up for grabs. So let's do a quick review over vertical angles and then definition of vertical angles. So if we go ahead in your interactive student notebook and you pull up your angles congruence sheet, over here we have the definition of vertical angles. So essentially what it says is two angles are vertical angles if and only if their sides form two pairs of opposite rays. So what the definition of vertical angles lets us do is say something like angle 1 and angle 2 are vertical angles. And then our reason would be definition of vertical angles. The vertical angles congruence theorem lets us go from what we just wrote a step further. This lets us go from stating angle 1 and angle 2 are vertical angles to then our next step can be saying angle 1 is congruent to angle 2. Not equals is congruent. All right. Let's go ahead and go back and work on a proof, and when we get to right angles, we'll come back and we'll look at the difference between the couple different right angles theorems we have. Okay, so the first statement we have, the given, is ray BF bisects angle AFC. So clearly the key word is bisects. So we need something about an angle bisector. Let's go check out our resource sheet. Definition of angle bisector, let's look at the example. Ray KM bisects angle LKJ. If and only if it makes two congruent angles. So basically, since we know bisect, we can state the two angles are congruent. So if we know BF is doing the bisecting, that's right here, and it's bisecting this angle AFC, then it is creating two congruent angles. So we could say angle 1 and angle 2 are congruent. So angle 1 congruent to angle 2, and the reason on that proof resource page, it was definition of angle bisect. So let me write that down. Definition of angle bisector. If you want to abbreviate, just put bisect, that's fine. Okay, now angle 1 and angle 4 are vertical angles. So look where angle 1 is, that's right here, and angle 4 is right here. All right. And that's just because on the picture you can tell they are vertical angles. So that is the definition of vertical angles. It lets us say, hey, you have two vertical angles. You can literally state it from a picture. So angle 1 and angle 2 are vertical angles is the example. Ours are angle 1 and angle 4. So we can state angle 1 and angle 4 are vertical angles because that's the definition of vertical angles. It's literally something of what it means to be vertical. So now since we know they are vertical angles, we can go one step forward and say, hey, these are congruent. And we can do that because of the vertical angles congruence theorem. That's the one that lets us go the next step to say, okay, you got vertical angles, then they are congruent. So vertical angles congruence theorem lets us go that last step. Okay. So now it says on line 5 we're doing substitution. So if we're doing substitution on line 5, that means somewhere along the way, lines 1, 2, 3, and 4, we're substituting something. So it definitely is on line 2 and line 4. So if they're having angle 1 is congruent to angle 2 and angle 1 is congruent to angle 4, what I think we're doing is we're saying, hey, if angle 2 is congruent to angle 1, then wherever I see an angle 1, I can swap it out and plug in angle 2. So I can take out the angle 1 and plug in the angle 2. So I'm going from line 2 and plugging it into line 4. All right, so now we're going from angle 2 congruent to angle 4 to angle 2, measure of angle 2 equal to measure of angle 4. And when you just switch from congruent to equals or equal to congruence, that's definition of congruence. All right, let's try another one. So real quick, let's stop and review right angles and see what we have on our resource page to kind of figure out what we have to work with here. So if you look up here, the first two angle ones, we have definition of a right angle. And basically, you can have, if they say something's a right angle, then you can say it equals 90 degrees. Or if you know an angle equals 90 degrees, then you can say, cool, that angle is a right angle. It goes both ways. When you have if and only if, it's a biconditional and it goes both directions. All right, so the right angle congruence theorem lets you say if you know both angles are right angles, so like angle 1 is a right angle and angle 2 is a right angle, then you can say angle 1 is congruent to angle 2. Okay, let's see if we can use any of those. So we have definition of a right angle and right angles congruence theorem. So the given said angle BAC is a right angle. And then the other given said angle 2 is congruent to angle 3. So we used both givens, that's good. So now they want us to use definition of a right angle. So if BAC is a right angle, then you know that the measure of angle BAC equals 90 degrees, because that's literally what it means to be a right angle. That's why we use definition of a right angle. Okay, so now angle 4, or line 4, I'm sorry, doesn't really tell us much. We don't have anything on the statement or the reason side. So if I'm not sure where I'm going until I kind of get better at formulating a proof, I'm going to look at the next line and be like, okay, this is where we're going, so what's the in-between step I need to get there? I've got to build a bridge. So line 5, we need measure of angle 1 plus measure of angle 2 equals 90. Well, if you look at the image, here's angle 1 and angle 2. So I think before we can do anything, we probably need to do the angle addition postulate. And that just says two angles that are adjacent added together equal the whole angle. So measure of angle 1 plus measure of angle 2. And what could you call the whole angle that angle 1 and angle 2 make? All right, you could call it measure of angle BAC or CAB. All right, so that's the angle addition postulate. So now we've got to look at line 5. So look from 4 to 5. We had measure of angle 1 plus measure of angle 2. That's the same. All right, so that's not different. So now we have BAC, but they took it out and they wrote 90. So they must have swapped it out sometime. And when they swap something out, that's substitution. So I see right here, they know that BAC equals 90. So they're like, hey, I'm going to take out this BAC and I'm going to write 90 instead. So that's substitution. And that was line 3. And they plugged it into line 4. All right. So now, out of nowhere, we have on line 6, measure of angle 2 equals measure of angle 3. Okay, that doesn't have any reason in above of why that could be other than look at line 2. So line 2 right here, angle 2 is congruent to angle 3. Now, angle 2 equals angle 3. So all they did was switch it from congruence to equals, so that's definition of congruence. Okay. So line 7, once again, we've got just blanks on both the statement and the reason side. So we've got to figure out where we're going. So let's jump down to line 8 and figure out what we're trying to get to and see if we could state something in between. All right, so line 8 says angle 1 and angle 3 are complementary. What does it mean to be complementary? All right, it means two angles, in math at least, it means two angles that add up and equal 90 degrees. So to be able to say angle 1 and angle 3 are complementary, we have to be able to say angle 1 plus angle 3 equals 90. That's the bridge we need to get to line 8. So how can we do that? What gives me the power to write that on line 7? Well, let's take a look again with our trusty highlighter. Okay, so I had angle 1 plus angle 3 equals 90. Well, that's the same thing on line 5. Angle 1, except not angle 3, equals 90. So somehow they went between lines 5 and 7. They managed to go from angle 2 in the middle right here to angle 3. So what I think they did is right here, they were like, hey, angle 2 equals angle 3. Therefore, I could swap them out and be like, hey, by angle 2, I'm popping in angle 3. So they're taking angle 3 from line 6 and plugging it in to line 5. They're trading it out, so that's substitution. And that gets us the fact that angle 1 plus angle 3 equals 90. And that means the two angles, angle 1 and angle 3, are complementary because what it means to be complementary is two angles that add up and equal 90 degrees.